Hello guys, welcome to our channel Bugfree. Hi, this is Vishal. So today's topic is scaling, right? So this is a very important topic in the field of computer science. So scaling we can do by two ways. One is upscaling and second is downscaling. Upscaling means increasing the amount of resources allotted. Downscaling means decreasing the amount of resources allotted, right? So how can we incorporate this in our studies or understanding, right? So let's see. Let's say we have a CPU and RAM, right? A system, we have a CPU, say i5 3 gigahertz CPU and 16 GB RAM we have, right? Now, in order to increase the power of this system, what we can do is we can add one more cores, extra cores, right? Increase that will lead to increase the number of the hertz here, right? The number of cores increases the number of the processing for the CPU. Also, the memory size you can increase at 32 GB, 64 GB in the power of 2. This is one way of increasing the processing power, you can say, for example. Now, this is an example. This is an example of upscaling. Now, what is downscaling? Downscaling means basically say it has 8 cores, right? It was an octa-core. We decrease the number of cores available. We decreased for 4 cores. It became a quad core. Then we decreased to 2 cores. It became a dual core system. Correct? So this is the example of doing upscaling or downscaling. Now let's understand what are the different types of scaling. Okay, we understood about what upscaling and downscaling is. Let's understand what are different types of scaling. Okay, there are mainly two types of scaling. One is horizontal scaling and the second one is vertical scaling. Okay, horizontal scaling is also known as sharding. Okay, horizontal scaling is also known as sharding. It's a other name of horizontal scaling. Now, what is vertical scaling and what is horizontal scaling? Let's understand this. Yeah, so as the name suggests, vertical scaling means we are adding resources. For example, that is, it is a vertical way. In this way, it will increase the power of the computation or the memory size or something, right? For example, let's say the early example that I added. Let's say we have a system which had i5 2 cores, which was dual core, and 4 GB memory, that is RAM, right? DDR4 you can say, or LPDDR5, something like that, right? Now, in order to increase the power of the system, what you can do? You can do one thing. You can add more cores to this particular i5 processor. Like you can make it to 4 cores, that is quad core, and then or else you can even further increase the power to more 4 more cores you can add it. It became an octa core, right? Now, to increase the memory, it became 4 GB to 6 GB, 8 GB, 16 GB, 32 GB, 64 GB, and so on. But there is a limitation here. Vertical scaling has a limitation that this is a limited amount of computation power. The cores, processing the cores or the memories that you are adding it. There is a limitation to that. How much you can add. Also, when you are adding it to this vertical scaling, the cost of overall it is very high. Okay, so it is generally not preferred much. Now let's go for horizontal scaling. Now, as you are expecting it and you are guessing it right only, horizontal scaling means scaling horizontally. Now, what does that mean? Correct? So we are scaling in this way. what we'll do here is that, let's say the same example, we had a system of i5 2 cores, right, and 4 GB RAM. What we will do here, in order to increase the overall processing power as well as the memory, we will add one more system here, i5 2 cores 4 GB. If you want to increase the power further, you can add one more i5 2 cores 4 GB. Now what happened here? The number of resources you can add is infinite. You can add as much as you want, right? There is no such limitation on what's the maximum size or maximum processing power you can have. You can add as many i5 dual core processors as much you like, right? There is no such limitation here. This is the concept of horizontal scaling. Okay. Now, since we have divided this, right, these are identical to each other. This is identical, and these all three are identical to each other. Now, if you want, you can apply vertical scaling on any of these items, right? Now, what are these single chunks of chunks called? These are called shards. Each of them are called shards. Each of them are a single shard. Okay. You can do vertical scaling here. For example, you can add, instead of 2 cores, you made it as octa core. Instead of 4 GB RAM, you made it as 64 GB RAM. You add that here. Correct? Now, how does it help our system? So let's see in that. So in our previous video, we learned about hashing and partition keys, right? So we'll apply the concept of hashing and partition keys here. Okay. So database scaling here happens in two ways, right? DB scaling happens in two ways. First one is called sharding, and second one is called partitioning. Okay, sharding and partitioning. Now what happens here is that, let's assume that we have a table called employee, right, and a department table. Two tables we have, right? Now what we'll have here is that, suppose the number of employees is growing like crazy. Okay, in that way, what will happen is that how to maintain data there, or the fetching of records there becomes a big task. It takes a lot of time to traverse the data, fetch and process them, and then return back as a response. So what happens here, we'll apply these two techniques so as to improve the performance. So how does it happen? So let's say we have a table, employee table, right, and we have a lot of records here. ID is there, name is there, obviously this is employee ID, and then designation, let's say, right? Let's say this table is there. So how will we make it into shards or partitions, right? We have a partition key. We learned the concept of partition key earlier through hashing, right? That partition key will be applied on these IDs based on some hash function. So let's say the ID is 1, 2, 3, 4, right? Then someone's ID is 10, 12, right? If you don't know about hashing, please go through and watch our previous videos. You'll be able to learn it very easily, right? So what happens here is that we'll have a hash function f of x here. Let's say the function is such that x modulus of 4. Okay. So this IDs will be taken as the partitions, right? Based on these partition keys, the value of this will be like that. So the remainder here, the partition keys will be like that, 0, 1, 2 and 3 here. Okay. So when 1 came, when we put 1 as x, the value will become as 1. When we put value as 2, it become 2. 3, it will go for 3, right? So instead of writing it here, let me write it down here so that it can be understood easily. So these are the partition keys here, right? So this one went here. Sorry, this one went here, this 2 went here, this 3 went here, but this 4 went for 0, right? When we go for 10, it will go to partition key 2. When we go to 12, it will go to partition key 0, right? So what we have done here is that we have divided this whole table into small chunks, right? In a single database based on the IDs. So here the partition key is the ID, employee ID, right, of this employee table. So what happened here? We divided it into 4 different chunks. Here, the table structure or the schema remains same in both cases of sharding and partitioning, right? So in this way we have divided. So there will be like within employee table only there will be 4 different partitions here then. Okay. So say we search for get by ID, and the ID pass was 5. Okay. It will simply check with the hash function. It will apply this 5 here. 5 modulus 4 equals to 1. It will simply go for this partition, right, and check whether this one has it or not. It doesn't, so it will return not found, 404 not found error. Okay, so this is about, and this is partitioning. Now partitioning happens within a single database. Sharding happens when multiple databases or database servers are there. Okay, in that case what will happen? Say we have a list of here 12 list of different databases, you can see here. Okay, so every database there will have the same schema, same table structure with the same columns. So let's suppose we have 10,000 records there. So what we'll do, we'll simply select a count. For example here, by remainder 1000. Okay, we'll divide it by 1000. For each 1000 records, we'll change the shard. We'll change a different shard. For example, this is a DB1, DB shard 1, DB shard 2, right? So what will happen here in this case is that, right, here instead of this, what we'll do, the ID number, ID by 1000, whatever value will be there, right? Let's say f of y. This is the hash function here. ID by 1000, whatever the value will be there. Let's say the value is x. Okay. This value will determine to which shard the data will get entered. Okay. So let's say 1000 is there, right? So if I have the ID as 999, the value is 0 when divided by 1000. So it will go to shard 1, or you can say shard 0, right? Okay, this is shard 1. Now if the ID is say 2500, that time we don't have any shard, right? So that time a new shard will get created. Okay, and the data will be inserted in that shard. If we have an ID of 1600, then we have value of 1600 by 1000 equals to 1, right? So this ID data, when HTTP post request is done, it will be stored in this shard, and as per the ID when we are fetching, same way we'll go to those shards and fetch those values. This is all about DB scaling, sharding and partitioning. Don't forget that sharding happens when there are different databases or different database servers. Okay, and partitioning happens only when there is a single database. Okay, same database, same tables are there. Within the tables we are having the differentiation. So this is all about database sharding and partitioning. Hope you like this video and this helped you a lot. I'm thankful for this.
Zara, sabar karo. The video is not completed yet. If you like the video, please like, share and subscribe.